Hey, physics. So I was looking back at what we needed to study for this test, and I realized that I did not do a very good job of teaching you guys about electric fields yet. So this presentation is all about that, and all of these mysterious grandma pictures that you're seeing here will all be explained as we go through. So to start off, you probably have seen some magnetic fields recently. Electric fields are very similar to that. They've got these looping bands, they've got directionality from one pole to another, they can be protective, you can see how that motion goes. But one difference is that with magnets, when you cut a magnet in half, it repolarizes itself. So you get like, if you got a north-south magnet, then they both turn into like norths and souths. So like these two sides will stick together. And same. The more you cut them, the more that they will, like they just always have that polarity there. But with electric fields, like the tape, we could separate them and each tape has a different charge on it. So that charge can carry into objects. So first thing you need to know about electric fields is that positive electric fields point outwards. And the way that I like to remember this is that my grandma is like this. She stays at her house mostly, but she is making cookies and sending cards and phone calls to everybody. She's got so much love that's just like going outward and outward, but she stays in one place. This is her staying in one place. This is her bringing cookies everywhere. So then we have negative electric fields that always point inwards. And that's like, you know, the young people in our lives, like myself with my grandma. Like, I'm like, I'll take the cookies, right? And I'm always seeking new experiences. I want to like bring things into myself and like, you know, just like experience new things, try new things, just like this negative electric field, right? So when electrical fields of opposite charges come together, they make this cool shape that looks a lot like that magnetic field that we saw earlier. So we have this Cookie Monster that is totally satisfied. He's like taking in all those cookies and he's just like, yeah, this is so good. Getting all that energy from that positive, all the charge, all the positive charge from that positive particle there. And you can see these loopy arms, kind of like a grandma pinching the cheeks of of her negatively charged young kid. Okay. And I want to back up because on this one I didn't really say this either, but with a negative electric field on its own, there's no forces, right? This is just like Cookie Monster, just like sitting there thinking about cookies. Like there is nothing more that he wants, but he can't do anything about it because he can't see his grandma yet. And then on this one, this is her on her own, right? This is her positive electric field just, radiating outwards, but she's not going anywhere. There's no forces acting on her. She's just thinking about her grandkids and how much she would like to give them some cookies, right? Okay, so outward energy, outward charge, inward charge, right? Okay, and then we have this relationship there, right? Okay, but when we get two grandmas together, they kind of clash because they need their own space, right? Like they don't want each other's cookies. They're like, I have so many cookies in my house, you have no idea, right? So they repel, and you get this kind of effect where it's not that they're clashing, it's that they're like bumping up against each other. Like if you can imagine two balloons that are charged, right? And they have the same charge, they're gonna kind of like repel each other, just like the tape that we saw. This is what that electrical field looks like from a repelling charge. Repelling positive charge. So then we also have repelling negative charges, right? Negative electric fields. And this is like Cookie Monsters that are hoarding their things, right? So we're looking at these curved lines, and this is the shape. This is like Cookie Monsters hoarding all of those cookies. There's only enough for each one, right? So they can't be in the same space because they'll get in a fight. So they just repel. They just avoid each other, right? So important thing to know here is that electrical field lines never overlap. So this is me with my balloons, right? And if they're far apart, they have these big electric fields that never cross. They just go straight up and straight down. Meaning that if you put a positive charge in the middle of those, that positive charge would go straight up or straight down, right? And then if I bring those closer, it's not that those electrical fields overlap, it's just that they get more squished and faster, upward and downward. Okay, let's see. So another thing to look at when you're looking at electrical fields is that more electrical field lines means a stronger charge. So this is like the grandma that's just like hanging out reading. She's feeling kind of sick and tired and sore and whatever. This is like your grandma that's making you all the cookies. She's amazing. And this is like the power grandma who is not only making cookies, but she is also competing in strong body competitions. Okay, so just letting you know what the differences between those fields are. Okay, so what if we have two like-charged electrical fields, but one of them is a lot weaker than the other one? Well, this is like if you have a small Cookie Monster and a large Cookie Monster together. This one's going to have a lot more electric field lines. It's going to have a lot more, like energy around it. It's going to have a lot more charge. And this one is going to have a lot less, okay? So let's see. That's the end of my slide show. I hope that you liked it. I hope that it was helpful to think about these things. I use these as kind of like just ways to remember. Like obviously you don't have to remember the Grandma Cookie Monster stuff, but if it helps you to like cement it in your brain as like something that makes sense for whatever reason, then that's great. That I have always had fun in science with like coming up with just like silly things like that to help me remember things. So I hope that that helps you too. And if not, don't worry about it. But thanks for watching.